All right, hello once again. This is Jeff Scott of Rankin Technical College, and we've been talking databases. I've been bouncing back and forth between looking at some actual database stuff and looking at the book SQL, A Beginner's Guide, 3rd edition, which we have online and which you see on your screen right now. We're up to Chapter 4, Enforcing Data Integrity. This chapter is broken down into 3 different components: table-related constraints, assertions, and domain constraints. All right, the ones that we're going to spend the most time with are the ones that are in here. All right, now a database must be able to do more than just store data. It must ensure that the data it stores is correct. When you think about it, there are many companies today that don't have a brick and mortar presence. In other words, they may be operated out of someone's garage, out of a warehouse someplace, or whatever, and the only presence they have is an electronic online presence. And if somehow their data becomes corrupt, the data in their database, the company could go under. So, in order to ensure the integrity of the data, SQL provides a number of integrity constraints, which are discussed in this chapter. You'll notice that it's divided into 3 categories: table-related constraints, assertions, and domain constraints. The table-related are the most common, and that's pretty much what's discussed in here. Now, there's actually 5 different types of these constraints, and when we look at them here, this is again what we're going to be talking about. There are domain constraints, which are checks, table constraints, which are all these that you see here, and assertions, which again are checks. So we're concentrating almost solely on what you see down here under these table-related constraints. If you say something is not null, that means that you do not allow the field to be left blank. Okay? Null, which we'll talk about in this chapter, does not mean blank, does not mean 0, does not mean false. Null is the absence of a value. So if I'm working at an educational institution, as I am, and I ask somebody, what's your GPA? And they say, I don't know. Then the value of their GPA is null because it's unknown. It's much different than saying it's 0.0. All right? We'll talk about unique and primary key because there are similarities between them and there are differences between them. We'll also talk about referential integrity with foreign keys. Notice that you can do this on a column basis or on a table basis. We'll talk about what that is and what the difference is. So I've already started to get into this, but if you look on here under not null, as it says, null signifies that a value is undefined or not known. And you may have noticed that with virtually everything we put in here so far, we've added not null. All right? So if we look at our tables, a primary key can never be null. That's just a rule. All right? And this one says not null, meaning it can't be blank. Same thing here, same thing here. All right, these are the primary keys, so it's the same thing here, same thing here. So we're not allowing nulls in any of these, but let's say that we came in here and with one of those examples that we looked at before, if I still have those available, where we did this. Let's say that maybe not everyone has a cell phone, all right, which sounds funny today, but we could actually do this. And what that would mean would be if we didn't know the person's cell phone number, or if they didn't have a cell phone number, we could leave it blank. All of these we'd probably want to specify as not null. In fact, I'm going to come in here and put all of them in. And that would mean for all of those values, so in other words, I'm just lining stuff up here. You can use white space. You don't have to, but you can. All right. This means, again, by default, primary key values cannot be null. But this means the first name, last name, address, city, and state cannot be left null where there's nothing in there. But the cell phone can be. I believe if you leave off null or not null, I think it defaults to nulls are allowed. Could be wrong on that, but I'm pretty sure that's the way it is. Again, this is not the same as 0, blank, or the empty string. It indicates that a value is absent. What does that mean? Absent, just like in your days of school. Absent means not present. All right? Earlier we talked about what if you had a situation where you had two different fields that could both conceivably, either one, not both together, but either field could conceivably be a primary key. Well, you pick one, and that becomes your primary key. But if you want to make sure that the other one is not allowed to have, each other one must be unique, you can put a constraint in there that just says unique. So primary key and unique are similar, but they're not the same thing. Primary key, there can only be one primary key. It can have multiple fields if you need it, but there can only be one per record, and the primary key must be unique within every record. Unique allows you to require that a column contain unique values. So they sound the same, but there are actually differences between them. Unique is not a primary key. All right. Unique means, though, that I believe you can technically have one record for if it's set to unique that's null, because just one null would make that unique. So here on the bottom of page 79 and going up to page 80, they talk about, it says primary key constraints have two restrictions that apply only to them. That means not to unique, but just to primary key. A column defined with a primary key constraint cannot contain nulls. Only one primary key constraint can be defined for each table. You can have as many unique key constraints as you might need, but only one of those can be a primary key. So a primary key, again, our unique record identifier, is a special type of unique constraint. Even though it's not mandatory that each table include a primary key, you should always, always, always anyway, because it's the right way to do things. So even if people tell you, oh no, you don't need one of those, all right, if you want it to work correctly, work consistently, etc., you should always have a primary key. Again, it may be more than one field, but you should always have a primary key. I'm going to jump up all the way to page 83 here, talk about foreign key, okay? Now, we talked about this before, but I want to show you this. And that is, if I come in here, if I come in here and do something like this. So if you remember earlier, we had these two fields, these two tables. All right, we've got an ID field, and this isn't really a good example. Let's grab everything that we had here before. Employee number, and we're going to make it bad again, so to speak. So that we're going to put that employee number in there. We're going to put that so number is now gone. We're going to put the employee department ID in there. We're going to put the employee salary in there. And we're going to put the employee supervisor in there. So now all of those are inside of this. So now we've got two tables instead of three, which is totally fine, totally legit. But if you notice, that's a person's ID and that's a department's ID. All right? And probably what we do, right now there's no way to relate these two fields together. But what we might do is we might go and take the department ID, this field right here, I'm going to put an asterisk by this field, and I'm going to put an asterisk by this field. Those are our primary key fields. If I come through here and I add department ID, so if I add that so it looks like this, I have now added department ID. All right, so I've added the primary key field from department in as a non-primary key field in person. If I do that, all right, if I do something like that, that's what's called a foreign key. So with a foreign key, you take the primary key of one table, you add it as a non-primary key field in another table, so you're able to relate those two tables together. If I did not want to do that, all right, the only other alternative I have would be to create a table called something like person department, and I would put in there department ID, and I would put in there ID, and both of those fields, they would be what's called a concatenated primary key. So I could do that. If I did this, then I wouldn't need to take this field and put it in there. But that's what the author explains under foreign key constraints. What foreign key constraints allow you to do is not have, they make sure that you have what's called referential integrity. And what that means is that you don't want there to be any orphan records. There can't be a record out there that basically isn't under the control or under the purview of another table. All right? So, not a great explanation. So let's go back, as we've done before, let's go back into Wikipedia. And let's put in referential integrity. And it says here, it's a property of data which, when satisfied, requires that every value in one domain or one column of a table exist as the value in another table. For referential integrity to hold in a relational database, any column in a base table, all right, that is declared can contain a null value or only values from the primary key. In other words, when a foreign key is used, it must be valid and it must be existing in another table. It allows you to make sure you never have what are called orphan records. You never want to allow that to happen. This will only make sense when you see it more and more and more in action. It says when you create a foreign key, you must follow certain guidelines. The reference columns must be defined either using a unique or a primary key constraint on them. So as it says, the primary key is most commonly what's going to be used to reference your columns. A foreign key constraint can be created as a table constraint or a column constraint. You're going to see that in a minute. The foreign key in the referencing table must include the same number of columns being referenced. So in other words, if the foreign key is a primary key in another table and that primary key has two fields in it, the foreign key must have two fields in it. Finally, if you don't specify the reference columns, then the columns defined are used as the reference columns. So here is an example right there. So what it's saying is we're adding publisher ID, and the publisher ID references a field that's inside of the CD publishers table that's also called publisher ID. So as mentioned here, this statement defines a foreign key constraint on the publisher ID column. All right. And they have you run through an example of it. Let's go and take a look before we go on. Let's take a quick look at what is shown in the data that we have. So notice here, because this is a better way to show it to you. All right. Let's see. So here's a constraint. That's what these are. Primary key is a constraint, foreign key is a constraint. Many people start their foreign keys with FK underscore, FK for foreign key. So this is called FK label ID, and it says that the label ID that we have in this table references the label ID in the CD labels table. So notice it's a primary key. So it's what we talked about before. So the foreign key is a field that we added into the compact discs table. So we added it as a non-primary key field, but it is a primary key in another table. And we've done that so we're able to relate the two tables together to one another. All right, we're at 15 minutes, so I'm going to stop right now. And we'll pick it up in here on page 88, talking about the match clause. So we'll be back with that shortly.